Hello students. I'm going to jump in now to Module 13. This is about conducting an experiment. And so again, I'm not going to go through all of the pieces of conducting an experiment. I think the module does a really good job of doing that for you, walking you through. This is a great chance to do one of the experiments here related to listening to different types of music and seeing how you respond to it. So this is the famous Mozart with the rats experiment. So you get a chance to do that here in Module 13. I do want to take a moment to talk about a couple of the important pieces though. So what we've talked about early on is making sure we ask a good research question that we can get data from. This is about now conducting an experiment. Remember, that's a very specific type of data gathering. It's not an observational study, so we're not trying to make some inference about the population. What we are trying to do is make some type of cause and effect relationship. In order to do that well, one of the big pieces we have to have is random assignment. So the goal here is to do something. Okay, maybe we've already seen different types of drugs for treating depression. And what we saw in there was that there were three groups: lithium, imperamide, and placebo. Now, the reason that we have those three groups is to test different options, and then what we would want to do is gather our research subjects and then randomly assign them to those three groups. So remember, the first type of randomization is random selection. And if we randomly select people from the population, then that's going to be fantastic. That's really great. I'd love to randomly select. Unfortunately, for a lot of these that you're going to see, we can't really randomly select from the population because these are maybe focused on depression. So we can't just randomly pick. We'd have to randomly pick people who are coming to maybe a doctor's office or a psychologist to get help for depression. So make sure the big piece here is the random assignment. Again, if you randomly select, but then you don't randomly assign, you really bring up those confounding variables. So for example, if you had randomly selected people from Miracosta College, and then you kind of were saying, okay, I'm going to split them into two groups. And at the end of that, all of the women were in one group and all the men were in another group, you wouldn't really maybe be able to say that's a great distribution of people between the groups, because now it brings up perhaps another confounding variable. So random assignment is a really big piece, and that's why random assignment tends to create similar groups. So again, we're trying to control as much as we can to make sure that the impact of the research is demonstrating what we think might happen. Okay, so as you take a look, if you have kind of treatment 1, treatment 2, and then here's the goal, take a look here. If I do a random assignment, I want you to kind of take a look at this little applet that's included here. So this is my original group of people, and what you can see is that as I randomly put them, so some of the people will go into treatment 1 and some will go into treatment 2, the mean of those groups may not match the mean of the overall group. One of them is lower, one of them is higher. However, it's still a random assignment. So we don't want all the young people, all the young kids in one group and all the older kids in another. So let's click random assignment again. What if we again randomly assigned kids to this? We'll take a look. Now I've got 8.2 in one and 8.39 in the other, but they're very different looking sets of data. This one, most of the data is clustered in towards the middle. Here, there's not very much clustered towards the middle, with most on the outskirts. Random assignment again, and again you can see we're not always going to get the same exact groups, but it's our goal to create similar groups that don't include any bias, and we're trying to minimize the amount of confounding variables. Now let's talk a little bit about a couple other pieces here. So when we have these groups, one of the big pieces we want to do is try to control as much as we can. I mentioned that. But one of the nice pieces when you're doing an experiment is known as a control group. So you have to balance that. What is a control group? So in the rat experiment that you'll see, there were three groups. exposure to heavy metal music, exposure to music by Mozart, and no exposure to music at all. That third group would be what was known as control. And that control group then kind of demonstrates, hey, what would happen without either of these other pieces? And now sometimes and there's a mention here about kind of a hernia. So a hernia is a type of medical issue that usually requires surgery, but they're trying out different types of surgery. So what they might want to do is say the old style would be the control group, and the new style would kind of tell us whether there's a change in the type of surgery that we're performing. You do want to be careful. I know we've already talked about one group with the depression group where there was a placebo given out, and that's because psychologically there are times where you may actually have positive response to treatment even though you're not getting the treatment. So just the fact that you're taking a pill and thinking that you're going to get better can actually sometimes make people feel better and actually at times get better. So this is the placebo effect, and that's why we tend to, if we're, say, giving out pills or something like that to test something, we'll give out a pill that doesn't have any of the drugs in it whatsoever, so that, again, it makes it seem like everyone is in one of those groups. Now, what's important about that is making sure that there's also this aspect of blindness, and not visually blind, but it's the idea that we don't know what's happening. So a doctor coming in may give a pill to someone and he may know what it is, but that patient will not know, and that's called a single blind. And then there's a double blind where neither the doctor nor the patient know which pill or which type of treatment that person is getting. And that's kind of the gold standard. If we could, we want to have a double blind, and that's so there's a third party who manages all of this other stuff. The doctors don't know, the patients don't know. Okay. And lastly, what I wanted to show you again with that random assignment is there is still chance variation. We're doing our best to control for it, but there is still some chance. They might be, if I randomly assign them, there still could be a difference in age between them. And it might be that our results are then confounded by age, so that variable might make some issues for us down the road. In any case, I think kind of understanding how we can try to control bias, how we can try to get everything we want out of an experiment, that's all that Module 13 is about. It's one of the shorter modules. I still hope you enjoy it. I hope you learn some pieces about how we can conduct a good experiment and why it's so important to follow these steps before we just start looking at the data. All right. Okay, so coming up after Module 13, we do start talking about an introduction to inference, and that's again part of that big picture as we start making the rest of the cycle. We're kind of swinging back to make an inference about the large group. So you'll also have not just a module checkpoint, but you will have a unit checkpoint at the end of Module 13. So take a look at that. All right, off you go.